Hi, in this tutorial, Tutorial 5, Section 6, Part 2, I will be continuing the tab container program. In this part of the tutorial, I will be creating a numerical keypad using button controls, including describing the necessary program code needed to implement a functional numeric keypad. After relaunching the Tab Experiment program in the IDE, we can begin working with button controls and program code on the Buttons tab. Now we will be adding some button controls to the program. The primary use of button controls is to allow a user to click a control to immediately execute some function or program action. In this case, we will be creating a calculator-style keypad for number entry. So this tab will be the tab with the most complexity. We will start by placing a button control within the Buttons tab. Don't forget, before placing the button control in the program, make sure that the control will be placed in the proper location by clicking Tab 4 on the tab container. I know this seems redundant at this point, but I cannot stress how easy it is to place a control in the wrong place. For example, the parent container instead of the desired target container. Again, this is really easy to do once you are using multiple controls within multiple containers within a project. And honestly, even after doing this sort of thing for years, I still often make this annoying mistake. Now, create a square button control. This can easily and more precisely be done by resetting the button's height and width properties to the same value, say 60 for both dimensions after the button is initially created. Next, copy the first button and paste 2 more copies of the button on the Buttons tab. Position the 2 new buttons next to the original button, equally spaced in a small row, and place the row around the lower middle of the tab. The leftmost button should be named Button 1, the middle button should be named Button 2, and the rightmost button will be named Button 3. The reason that this arrangement is important is to make using the buttons easier for code once the tab is fully populated with the buttons. Once there are 3 horizontal equally spaced buttons, select all 3 buttons. Click on the first button, hold down the Control key, and click on the other 2 buttons. Now, copy the 3 buttons and paste a new row of 3 buttons within the Buttons tab. While the new row is still selected, use the mouse to drag the second row just above the first row. Make sure that the new buttons are arranged from left to right as Button 4, Button 5, and Button 6. If they are not in that order, just click outside the group of buttons and click on the button you wish to move to use the mouse to drag and arrange them in the correct numerical order. Next, copy all 3 buttons from the bottom row and again paste 3 new buttons onto the Buttons tab. While the newest row is selected, use the mouse to drag the 3rd row just above the 2nd row from the bottom, and verify that the top row of buttons are arranged from left to right as Button 7, Button 8, and Button 9. Finally, paste another copy of the 3 bottom row buttons onto the Buttons tab, but drag this row down under the bottom row. Now we are going to rename the button objects in the bottom row to make their identities easier to manage. Set the name property for the leftmost button to button_clear. Set the middle button's name property to button 0. And lastly, set the rightmost button's name to button_enter. Next, move the leftmost bottom button, the clear button, down and to the left to offset it from the keypad arrangement that has been created. Also, stretch it out to be more rectangular. Finally, also make the rightmost bottom button the same size as the leftmost bottom button and move it down and to the right to make it mirror the bottom leftmost button's position. The result of all of this is to create a numerical keypad that resembles a calculator with 2 larger, visibly offset buttons below it. Now that the geometry of the keypad is set up, change the text property of the buttons to their corresponding numbers, i.e. button 1's text property should read 1, button 2 should read 2, etc. Once the numerical keypad arrangement, often called a 10-key arrangement, is finished, set the leftmost bottom button's text property to the word clear, and set the rightmost bottom button's text property to the word enter. The last characteristic of the buttons that need to be changed is to select all of the buttons and use the editing toolbar quick buttons to make the text on the buttons bold and to increase the font size for the best appearance. Next, also add a LCD label control from the toolbox to the Buttons tab. Place the LCD label control centered over the button controls. Set LCD Label 1's foreground color and highlight color properties both to green. Set LCD Label 1's background color to black. Set LCD Label 1's alignment property to right. And lastly, set LCD Label 1's text property to the number 0. All of this will create the appearance of a calculator-style display when the program is running. Finally, set the clear button's background color to soft royal. And then do the same for the enter button. Again, save the project at this point and go ahead and run it to test out the button tab's appearance. Now, to add some code to the button controls to make them functional. And here is another programming observation. There are usually many ways of accomplishing any specific programming task, and generally there is no one right way of doing something. Efficiency actually has many different metrics, and the priorities of a software project may include reducing the time it takes for a computer to accomplish a task, ease of creating and maintaining the software, utilizing minimum system resources, meeting a design aesthetic, or integration with other systems and software. And all of these priorities have many variations, relationships, and nuances. And realistically, there are many opinions on all of this. However, my personal position is generally that, barring special design priorities or requirements, reliability and ease of functionality both at design time and runtime should usually rank very highly. Therefore, although the code in this example is repetitive, and there are other more sophisticated coding methods to accomplish this functionality, which will be discussed as more advanced coding examples are demonstrated, this example is a simple, straightforward approach that works reliably thanks to its simplicity, and it is designed to be easy to understand and modify. Due to this design choice, there will be a fair amount of redundant program code within the form class file to handle the button functionality. However, due to the simplicity of the code and its redundancy, the code is very easy to create primarily by copying and pasting. And this example is an exercise in reusing blocks of code and directly modifying the actual code in the form's class file. Also, thanks to the fundamental nature of Gambas object-oriented event-driven programs, the methodology of this code simply does not manifest itself as reduced speed of operation or excessive system overhead. This is due to the fact that the code elements visible at design time only execute when a user clicks a specific button control, and then only the code that is specifically utilized is actually run. To add the necessary code for the button functionality, we will be adding and manipulating code within the main form's class file. This code will be triggered when a user clicks a number button. So, first double-click on button 0. And in the form's class file, within the code block that begins button 0 click, enter the code if lcd label1.text equals double quote 0 double quote, then lcd label1.text equals double quote double quote. After that line, add the additional line lcd label1.text equals lcd label1.text ampersand 0. Note, this should be the number 0 for button 0. The first statement in this code uses an if-then statement to check to see if the currently displayed output on the LCD label is the single digit 0, and if it is, then the code clears the runtime display to prevent any potential leading zeros in the final number, which is displayed on the LCD label. This conditional code does this each time a new number key is pressed before the next program statement. At this time, it is important to note that if-then constructs such as this code are one of the most necessary programming elements. Fundamentally, this is the type of code that allows a program to be flexible and perform different actions based upon user input, internal or external data, or previous actions. You will see if-then decision-making constructs in essentially every programming language, from machine code and assembly language through high-level languages such as BASIC, Python, and the C language. In fact, if-then branching is so fundamental that it would be effectively impossible to truly program without it. So I will be covering the concepts of if-then conditional branching in Gambas Basic much more thoroughly as we get more deeply into the structure and use of actual basic language code. But for now, you can simply copy these examples to see the use of if-then statements. The next line of code in this project simply concatenates a new number string displayed on the LCD label each time a number button is pressed. The second line of code within each button event will add the newest number entry to the end of the existing number string, which is stored in the LCD label. Next, after the code in the button 0 event has been entered, you will need to copy the entire button 0 click event subroutine by selecting it and using Ctrl-C to copy it to the system clipboard. And then use Ctrl-V to paste the code block into the class file 9 more times. This is one subroutine per button, so we are creating 10 subroutines in total, one for each of the 10 numbered buttons, numbered 0 through 9. It is really important to understand that, at this point in modifying the form's class file, this code isn't finished yet, and it is effectively impossible for Gambas to run the program code until we have finished the next step to edit each button subroutine. So don't try to run it yet, though you can save your work at any point. Now, to make the number buttons code functional. We are going to edit each of the copies of the subroutines to create a functional subroutine for each number button on tab 4. Note, you could simply double-click on each one of the number buttons and then enter the code for each number key. But this copy and paste method really is faster, and I hope will also give a greater familiarity with editing the structure of Gambas class files. This should also help you become familiar working with subroutine code blocks. What we now need to do is edit each of the new copies of the original button 0 subroutines to correctly reflect each of the desired button press results. So, start with the first code block after the original button 0 code block. Change the start of the code block from the existing button 0 click event to be button 1's click event. Do this by changing the subroutine code block's first line, button 0 click, to button 1 click. This will create the code block which is called when button 1 is pressed by a user. Then we also change the line of code that sets the output of LCD label 1 to add the correct number entry for button 1. In other words, to add the number 1 at the end of the currently stored value when button 1 is clicked by a user. To do this, change the number after the ampersand to the number 1. Remember, Gambas simply executes the code in the class file as the program is running once the class file has been created at design time. So it doesn't matter how the code was created in the class file. The Gambas runtime simply executes the code for each event as they are encountered, as long as the code's syntax is correct. The important concept here is that each code block is a subroutine, which is run when it is called, either by an event such as a click or by another section of code calling the specific code block subroutine by name. Therefore, each object, in this case each number button, must have an event subroutine called an event handler for the program element to do something. And the event handler must be valid code which has the correct syntax within the Gambas language. Another thing to understand is that only one subroutine can exist for each event. These requirements will become clearer as we dive deeper into using Gambas basic code. As I said before, you could create these button code blocks by double-clicking on the individual buttons and letting the Gambas IDE create the class file code block entries, and then enter the correct program code for each individual button event. However, at this time, we have simply used copy and paste to create the necessary button event code blocks within the class file. And then we need to edit the new code blocks to conform to the actual button arrangement and functionality for the buttons, which we have created on the program form. In this case, I believe this copy and paste method is faster than creating the necessary code step by step using the IDE to create the code blocks for buttons 0 through 9, and then entering code for each number button event. This method also introduces the concept of manually creating and using subroutines, which is a very important Gambas programming concept. This concept will be needed to create more advanced programs later. Now, modify each of the 8 remaining button events to correspond to the buttons 2 through 9. Just remember, the start of each button event subroutine must be renamed to its new button event name corresponding to the number buttons on the form. And the second line of code in the button events code block must also be changed to reflect the value of the actual number button pressed by a user. After this much work, go ahead and save the project again. And after this editing, Gambas will be able to process the code that executes when the number buttons are clicked by a user. So go ahead and run the program to try out the number buttons. Finally, to add code for the last two buttons, the Clear and Enter buttons, move back to the Buttons tab on the form and double-click the Clear button. And in the code block that begins button, clear, click, add the code lcdlabel1.text equals double quote 0 double quote. This will reset the LCD label's text property to the single digit 0. And underneath that line of code, enter textarea1.text equals double quote double quote. This second line of code will completely clear the text area on the Text tab. And lastly, on the Buttons tab, double-click the Enter button. And in the code block that begins button, enter, click, add the code textarea1.text equals textarea1.text ampersand double quote space double quote ampersand lcdlabel1.text ampersand double quote space double quote. This code will transfer the number currently displayed on the LCD label to the end of the current contents of the text area control on the Text tab. It also places empty spaces before and after the number to keep the number separated from any text already in the text area. So these two buttons on the Buttons tab are also interacting with program elements on another tab. Here is a quick overview of the actual program code that is in the Enter Buttons subroutine. As stated, this program code stores the result of the target object's current contents along with a new, carefully formatted string containing the contents of the LCD label. The program code uses a series of elements discussed in earlier tutorials to create a new string containing all of the chosen elements. The final string is created and assigned to the text area on the Text tab using assignment and string concatenation operators. You can find this code in the Button Enter Click code block in the fmain class file below the video. Now that all of the elements on the Buttons tab have been created and the necessary code has been added, be sure to save the project before running the project again, just in case any mistakes have crept in. And with the program running, click on the Buttons tab again and click the various number buttons. Also test the Enter and Clear buttons to test out all of the button tab's functionality. Remember, the button tab's Enter button copies the current number from the LCD label to the program's text area control on the Text tab. And the Clear button clears both the LCD label display and the text area. In the next tutorial, Tutorial 5, Section 6, Part 3, I will be adding a ComboBox drop-down list and a PictureBox control to the tab program, and I will demonstrate creating the necessary code and setup to use those program elements. Again, thanks for taking a look at these videos and joining me as I explore the Gambas language and making these videos. I hope you find them useful.